Welcome all. Sorry I'm not there today to help you through this, but I just wanted to kind of start out and go through part of this lesson with you. On the first page, you're going to notice there's these different functions listed, and there's going to be really two that I want you to focus on: quadratic and absolute value. The rest you're going to need to know, but not as much. Quadratic, just make sure you understand it's a parabola. It's going to look like that. Absolute value looks like a V. We're going to get into reflection, so it could look like flipped over the x-axis. Then you have square root, which just looks like that, has a vertex here, and then cube root, which is continuous throughout the whole graph. Sorry that the copy didn't come through very good. Linear is pretty self-explanatory. So those are what we call the parent functions, the functions that we're going to transform. We're going to shift them. We're going to translate them to be specific: up, down, left, right. We're going to do some reflections. We're going to do some dilations, which means stretching and shrinking the functions. But that's what you're going to need to know, really, the absolute value and the quadratic especially. And I'd encourage you to refer back to this page quite a bit as you're working through today's lesson on pages 1 through 7. Okay, so obviously yours is not color-coded, but what I'm going to suggest that you do on this page, f of x, oh, hold on, let me get rid of this. All right, you have f of x and g of x. This top one is f, this bottom one is g. And I'm really just going to look at the vertex here. This vertex is at the origin. This vertex is at the point 0, -7. So the graph of g was just shifted down 7 units. So this -7 just shifted the graph down 7 units. Now we have absolute value. Same idea. This is f. This is g. You'll notice the vertex here is at the origin. The vertex here is at 0, -7. You'll notice the 7 is outside of the absolute value. And absolute value just means distance away from 0. That's a fancy way of saying that. So in both of these instances, the graph moved down 7, or translated down, or shifted down 7. Okay, as we go to the next part of this page, so you have this blue graph, f, or the one on the right on your papers, and the one on the left is g. Again, we're going to look at the vertex. Here it's at the origin. Here it's at 0, -2. So this graph shifted to the left 2 units. Now what you'll notice is that +2 is part of inside the parentheses. So this moved to the left 2. And now we have a square root function. The one on the right is f. The one on the left is g. Again, the vertex was at the origin, and now it's at -2, 0, so this shifted to the left. And you'll notice that +2 is within the square root, similar to the +2 being within the parentheses here. So this is going to shift the graph to the left 2, which is different than what we saw above, where the -7 was outside, and that shifted the graph vertically, in that case, down 7. All right, moving on to page 3, it's going to be more of the same here. Hopefully this is going to start to make some more sense. You have this graph. F is the one on the left. G is the one on the right. The original vertex is 0, 0. The other vertex shifted to the right 4. So it's kind of interesting. You had the -4 in parentheses. It's -4, but it's shifting to the right 4. We notice the same thing here with the absolute value. Let me erase that. That -4 is part of what's happening inside the absolute value. So it's inside. The original had a vertex of 0, 0. This has a vertex of 4, 0. So this shifted to the right 4. So again, it's inside, and it's doing the opposite of what we would think. It's a -4, but it's moving to the right in the positive direction, which is different than what we just saw, or I'm sorry, similar to what we just saw up here. The +2, that was inside, that was similar, but it was a +2. It's moving to the left in the negative direction instead of to the right. All right, the bottom of page 3, a little bit more of the same. Now we're back to outside. This is not part of what's being cubed. So you have your vertex 0, 0, and now it's 0, 5. This is function f. The red one is function g. So this graph shifted up 5. Again, it's outside of what's being raised to the third power. It was plus 5, so that makes sense. We assume it's going to go in the positive direction. It does. The second one, same thing. The plus 5 is not underneath the square root. So the original vertex was 0, 0. It shifted up to 5, 0. I'm sorry, 0, 5. So this graph shifted up 5. So we've gone through all the scenarios. You heard me try and kind of say inside, outside, and did it do the same thing we thought it was going to, or a different thing? And that's really going to be what we're going to be focusing on. The last thing that we're going to talk about here is dilations, like stretching and shrinking. So here we have graph F and graph G. So what you'll notice is graph G gets stretched vertically. It's closer to a vertical line. So we say this is a vertical stretch. You notice the same thing here. This is inside. It's part of the absolute value. And same deal. This red graph is getting stretched vertically. If I stretch it more vertically, it's going to get steeper and steeper and steeper. So both of these are going to be a vertical stretch of 2. Pardon my handwriting. Vertical stretch of 2. So it's basically just taking all the y values and multiplying them by 2. So it's stretching the graph vertically. All right, let's summarize here down below. All right, this is going to be a really important summary that really brings everything together in the lesson. I'm going to use some text so you don't have to try to read my handwriting. All right, this one, that minus k, this is a moves down k units. Moves down k units. Speaking of moving down k units. This next one, plus k, this moves up k units. Up k units. So what you'll notice that these both have in common, the plus k and the minus k. Let me use the text box so you can read what I'm going to write. Both of these, what did I just do? Okay, let me try this again. Both of these values, maybe I can't do it outside like I was hoping. All right, let me try this. Just inside here. Okay. If the number is outside of the function, it's going to be a vertical shift, and it's going to be the same. What the heck do I mean by that? So this is outside, vertical, same. So really, for these two. Outside, it's not part of the function. So if I had like x squared plus 3 versus x plus 3 squared, this plus 3 is outside of the function. It's not part of that squared. So that's what I mean by outside. Same idea with square root. The plus 3 would not be under the square root versus the plus 3 being under the square root. These are outside. It's going to be a vertical shift. So this plus 3 would be up 3. This would be up 3. And it's going to be the same direction as we think. Positive is going to move up. Negative is going to move down. Okay, now moving to what happens if it's inside the function. Inside the square root, inside the absolute value. No, that's not what I meant to do at all. All right, let's get a text box in here. So this is going to move left, and I'm going to capitalize this. Left k units. This does the opposite, and I tried to show you that where we were working through the graphs. It's a plus k, like plus 5, but it's going to move to the left. It does the opposite, and minus k is going to be the same idea. This is going to move moves right k units. There. Oh my goodness. Well, you saw what was up there. Left k units, right k units. I guess I can't copy and paste. Okay, so let's summarize here. Let me get another text box. These are going to be inside. All right, got it. Inside, horizontal, and opposite. So inside, horizontal, opposite. Inside, horizontal, opposite. So that's getting into this idea of, all right, going back up here, this +3, this is inside of what's being squared. This is actually going to do the opposite direction of what we think. It's horizontal, so it's going to move it to the left 3. This +3 is inside of the square root, inside of that parent function. Same deal. This is going to move the graph to the left 3 units. I don't know why I can't draw that. There we go. To the left 3 units. All right. If we multiply by k and k is greater than 1, so if you have like 2 times absolute value of x, that's what it means. This is going to be a vertical stretch of 2. Vertical stretch of 2. That's what that's going to be if it's greater than 1. And if it's, again, this is going to be outside, and it's going to be the same. If I multiply something by 2, it's going to get bigger. It's going to stretch. So this is very similar. Outside, vertical, same. Outside, vertical, same. So if this was like 1/2, this would be outside vertical same, and this would be a vertical shrink of 2. And I just realized I made a mistake up here. So, all right, I'm going to take this off, and let me come back up here. This one here, since this 2 is inside the function, this is going to be horizontal, and it's going to do the opposite. So this is going to be actually a horizontal shrink of 2. This is going to be a horizontal shrink of 2. Horizontal shrink of 2. Okay, that's going to be the first part of the lesson, and I'll make a different video for the second part.